Hello students, let us begin with a new chapter called as decimals. It is in continuation with the fractions, which was 7th chapter of your NCERT textbook. Let us begin with the definition part of decimal. What are decimals? A decimal is defined as a number expressed in decimal notation and generally applied to values that have a fractional part and separated from the integer side by a decimal separator. Let me consider an example. 56.8. Here there are 3 digits used. The digit 5 is in tens place, digit 6 is in ones place, and there's a decimal point, then there is tenths place. We will go in detail and learn what are these tenths place and how do we read this. Here it is 56 and 8 tenths. The decimal point goes between ones and the tenths. How do we read this? We read it as 56.8. Let us try to understand the place values in decimals. The place value system is used to define position of a digit in a number, which helps us to determine its value. When we write specific numbers, the position of each digit is important. Let me take an example. For instance, let us consider the number 345. The position of 5 is in ones place, which means 5 ones, that is 5. The position of 4 is in the tens place, which means 4 tenths, that is 40. The position of 3 is in hundreds place, which means 300. So we go left, each position becomes 10 times greater. Hence, we read it as 345. Once again, I'll take the number 345. Here 5 is in ones place, 4 is in tens place, and the 3 is in hundreds place. As we move left, each position is 10 times bigger. Here you can see when we move from right to left, each digit, its value increases by 10 times. Tens are 10 times bigger than ones. That is, 10 will be 1 into 10. Hundreds are 10 times tens. Same way, thousands will be 10 times 100. So each time you move towards the left, the value of the place increases by 10 times. It becomes 10 times bigger. What if there is one more digit over here? What will be the value of the digit? For that, I have considered an example, 345.8. Here, this is the ones place. This is tens place. This is hundreds place. You look at this, when we move from left to right, the place value decreases 10 times. Here, the tens place is 1 by 10 times the hundreds place. Ones place is 1 by 10 times tens place. So what will be the position or the place value of this digit? It has to be 1 by 10 times ones place. Yes, this particular thing is called as tenths. It will be 10 times smaller than ones place. It is 10 times smaller than ones place. Let us now discuss about types of decimal numbers. Basically, we consider two types. The first type is called as terminating decimal. What does a terminating decimal refers to? While expressing a fraction in decimal form, we perform division. We notice that the division is complete after a certain number of steps. That is, we get the remainder as 0. The quotient obtained as decimal is called as a terminating decimal. Such a decimal has a finite number of terms after the decimal point. I would like to give few examples for that. Suppose if I consider 17 upon 8. 17 upon 8 is a fraction. What does 17 upon 8 refers to? 8 divides 17. Let us perform division. 8 2 times is 16. When we subtract, we get the remainder as 1. So we place a decimal and take 0 along with the remainder. Now 8 one time is 8. I need to subtract. We get 2. Since we have placed the decimal, according to the rule, we have to consider 0 along with the remainder. Then 8 2 times is 16. On subtracting 16 from 20, we get 4. Along with 4, I'll place a 0. Now 8 5 times is 40. On subtracting 40 from 40, I get the remainder as 0. Since remainder is 0, therefore 17 upon 6, which is 2.125, is a terminating decimal. There are 3 decimal places after decimal, so it is having a fixed number of terms after the decimal point. This particular example, 17 upon 8, on expressing in a decimal form, we get a terminating decimal. Let me take another example, a simple one. I'll take a number 1 upon 4. Now 1 upon 4, if you want to express in a decimal form, I need to divide 1 by 4. 1 is a smaller number than 4, so I have to take 0 point, then 2 times is 8. On subtracting, we get 2 as a remainder. Place a 0 along with the remainder. 4 5 times is 20. Now on subtracting, I get the remainder as 0. Since remainder is 0, therefore 1 upon 4 is terminating decimal. 1 upon 4 is nothing but 0.25, which is a terminating decimal, and it has got a fixed number of terms after a decimal place. The next type is called as a non-terminating decimal. What does a non-terminating decimal refers to? While expressing a fraction in decimal form, when we perform division, we get some remainder. If the division process does not end, that is, we do not get the remainder equal to 0, then such decimal is known as a non-terminating decimal. So for example, if 1 is divided by 3, we'll be getting 0.3 times is 9. Subtract 9 from 10, again I get 1. Place a 0. 3 times is 9, and this particular process continues. Note that in some cases, a digit or a block of digits repeat itself in the decimal part. Such decimals are called non-terminating repeating decimals or pure recurring decimals. These decimals are represented by putting a bar on the part of a repeated part of the decimal. Here in this example, when you observe, when I divide 1 by 3, divide 1 by 3, I get 0.3 recurs or 3 repeats. So I can write bar on this digit 3 such that it indicates that the digit 3 is repeated. Example for a non-terminating decimal. First one, 2.6666 and so on is a non-terminating repeating decimal. It can be expressed as 2.6 bar. 2.6 bar. One more example, 0.141414 and so on is a terminating decimal. Sorry, non-terminating repeating decimal. Here there are 2 digits which are repeated. It is 0.14. In some cases, at least one of the digits after the decimal point is not repeated. Such decimals are called as mixed recurring decimal. Here, observe this. Only 4 repeats after the decimal. This is a mixed. Here only 3 repeats after the decimal, and here only 5 repeats, and the first digit after the decimal is not repeating. These above examples are the examples for a pure recurring decimal. Pure recurring. These are the examples for mixed recurring. So there are two types of recurring decimals. Pure recurring decimal means the digit after the decimal point repeats. Mixed recurring decimal, which means the digit soon after the decimal will not repeat. Some digit will start repeated. Here you observe the second example, 8.12. After that there is a digit 3 which is repeated. Look at the word decimal fraction. It represents a fraction whose denominator is in powers of 10. I'll give an example. 81.75 is same as 8175 upon 100. 32.425 is same as 32,425 upon 1000. Converting the decimal number into decimal fraction, for the decimal point place 1 in the denominator and remove the decimal point. 1 is followed by the number of zeros equal to the number of digits after the decimal point. Here 81.75, there are totally 2 decimal after the decimal point. So the decimal is replaced with 1 followed by 2 zeros. So it is written as 8175 upon 100. 8 represents the power of 10 raised to the power 1, that is 10th place. 1 represents power of 10 to the power 0, which is units place. 7 represents 10 to the power minus 1, which is 1/10th place. 5 represents 10 raised to the power minus 2, which is 100th position. So each digit is represented by a particular power of 10 in the decimal number. If I want to express in an expanded form, this should be expressed as 8 into 10 raised to the power 1 plus 1 multiplied to 10 raised to the power 0 plus 7 multiplied to 10 raised to the power minus 1 plus 5 multiplied to 10 raised to the power minus 2. This particular thing is a expanded form of the decimal 81.75. Now let us learn place value of a decimal number. The place value is obtained by multiplication of the digit in the decimal number, which is with its power of 10. That is, digit holds at this position. I'll give you the place value chart. Power of 10 can be found using the following place value chart. You observe here there is a decimal point. Towards the left of the decimal point, we have the place values like ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, etc. Towards the right side of the decimal point, we have tenths, hundredths, thousandths, 10,000s, 100,000s, millionths. The digits to the left of the decimal point are multiplied with positive powers of 10 in increasing order form from right to left. Here it is nothing but 10 raised to the power 0. This is 10 raised to the power 1, 10 raised to the power 2, 10 raised to the power 3, 10 raised to the power 4, 10 raised to the power 5, 10 raised to the power 6. Whereas the digits to the right of the decimal point are multiplied with negative powers of 10 in the increasing order from left to right. Here we have 10 raised to the power minus 1, 10 raised to the power minus 2, 10 raised to the power minus 3, 10 raised to the power minus 4, 10 raised to the power minus 5, 10 raised to the power minus 6, and so on. With this, I'll conclude today's session. In the next session, we shall learn how to represent the decimal number on the number line. How do we compare two decimal numbers? What are like decimals and unlike decimals, and so on. That's all for today's session. Thank you.